Let's take a look at a line of sight and talk about raycasting. Alright, we find ourselves back in Unity once more, and in this tutorial we're going to be talking about line of sight. This comes as a suggestion from Archangel Azrael, because last time we did following the player. So basically these little crabs over here are following the player. We can actually take a look at this. You can see they're basically following the player in the exact position where the player is at. So that is pretty cool. But they asked, okay, how could we do line of sight, right? So how could we maybe make a wall between, and then the enemy is actually not going to follow the player, and we're going to implement this right now. This code without the modifications is also going to be available to you in the description below as a Unity package. So you can basically start from exactly this project with the enemy follow player script, and let's take a look. So basically, we just want to change this script a little bit, and what we're going to do first and foremost is we're going to have a private bool called has line of sight. And this is going to be false by default. Per default, the enemy does not have line of sight to the player. And then what we're going to do is we're going to use raycasting. So raycasting is a very cool thing that basically allows you to draw a line, let's say, or cast a ray from one position into a certain direction, and then tell whether or not it's going to have a collider or hit anything along the way. This will happen in the fixed update method. And what we're going to do is we're going to do this by making a raycast hit 2D. You can see this one. We're going to call this the ray. This is going to be equal to physics2d.raycast. So this is a raycast method right here. The first parameter of which is going to be the origin, as you can see, and then it's the direction. This is extremely important to think about. This isn't going from this position to this position. It's going from this position in this direction. So the position is going to be transform position. That's fine. So this is going to go from the enemy, and then to get it to the direction of the player, we want to say player.transform.position minus this position. So this is going to be transform.position, because this gives us the direction. This is basic vector math. I highly recommend checking out some of that if this might be confusing or interesting to you. This is basically how you get the direction from this position to this position. And with that, we can basically then say, hey, if the ray.collider is unequal to null, basically meaning we have actually hit something. But if this is the case, then we can say has line of sight, and then we're going to do something really cool. We're going to say ray.collider, and we're going to look at the tag. So we're going to compare the tag, and if it's the player, then we have line of sight. And if it's not, then this is automatically going to be false. So that's really cool. And then just to help us see a little bit better, we're going to make if has line of sight, we're going to debug.draw, and this is awesome. We can draw a ray. So we're going to draw a raycast, and we're going to basically put in the exact position and direction that we are using in the raycast over here. So this is going to be, once again, transform.position. And then the direction, once again, is going to be player transform position minus transform.position. And we're going to do this in color green. So basically, we're going to draw the ray in green when there is a line of sight. And then we can do an else statement right here. And what I'm going to do is I'm going to copy over the debug. There we go. So I'm just going to select this, press Control C, and then Control V to paste it in. And then here we're going to make a red. So basically meaning that if there's no line of sight, then the ray is going to be colored red. Otherwise, it's going to be colored green. And then the last thing we want to do in the update method is we want to only do the position change over here if the line of sight is true. So we're just going to take this, cut it out, Control X, and then Control inside of the if statement. And now only if has line of sight is true, then are we actually going to move towards the player. And that is actually all that we want to do here. This is everything that we need with an inbuilt cool debug over here. This is, of course, something that in the game itself would not be a thing, right? You really wouldn't be able to see the line of sight, but this is really good for debugging purposes. So if we now jump back into the game, in theory, everything should be set up. The enemies have the enemy follow player script. And what's very important is that the player has the player tag right here. That is, of course, quite important. And what we're going to do is we're just going to add these bricks over here as walls, right? So we're just going to, let's size them up a little bit so that we basically take a look at whether or not this is going to properly work. Let's do a 5 by 5. That's good. Oh, not a 55. That is a little bit too big. Maybe that's going to be enough already. So just something like this. I'm going to duplicate this, Control D. Just so that basically like both of them, like all of them have no line of sight when we're starting. And to actually block the line of sight, the bricks right here need a collider. So in this case, we're just going to add a box collider. This is going to add a simple collider basically on top of the entire bricks game object over here. And what's of course also important is that your player also has a collider. Otherwise, the raycast is not going to work. And there's another step if your crab, in this case, our crabs do not have a collider. If your enemies also have a collider, you're going to need to ignore that. We're going to take a look at that in just a moment, because usually your enemies will also have a collider. Let's first of all take a look at it like this, and we're going to see, if we go in, you can see all of the rays are red, right? And if I move over here, and you can see this is going to sneak through, there you go. So there it has line of sight, and it turns green, and it starts following me. I mean, this is a really, really freaking cool effect, and it's pretty straightforward, all things considered, right? Like, it's not that crazy, as you've seen, right? So there you go, and now I can't escape anymore. No, there you go. So that is going to be the line of sight like this. And then one of the issues you might run into, if one of your crabs or one of your enemies, right, has a box collider 2D added to it, you will now find that if I try to go into the line of sight of it, you will see it does not work, because basically it's actually detecting itself, and it says, no, I can't see the player because I'm seeing myself, which of course is, I mean, number one, kind of ridiculous, and number two, it's not really going to work. Now, there are actually a plethora of ways that we can fix this. So one thing would be, under the layer right here, we're just going to use ignore raycast on the crab itself, and then what's going to happen, if I go into the game again, you will find that now the crab follows me without any issues, because basically it's ignoring the raycast is ignoring the game object that we've specified right here. So that works totally fine. Another way that you can do this is, instead of using raycast, you could also use raycast all. Now, the difference here is going to be, if I hover over this, this is now a raycast hit array. Basically, this is going to give you every single raycast hit along the way. So it's not only going to give you the first one that hits, right? So in this instance, right, obviously only the first collider that is going to be hit with the raycast is going to be converted into a raycast hit. With raycast all, you're going to get the crab, and you're going to get the wall, and you're going to get the player. And if there's maybe something behind the player, you would even get that as well. This is also feasibly how you can do this. The ignore raycast here is probably going to be the easiest way to facilitate this. Raycast all might be a more robust way if, for example, there's going to be something else that you need the raycasting ability for your enemies for. But yeah, that is line of sight for your enemies. Pretty freaking awesome. And that's already it for this tutorial right here. Now take your line of sight and put it to this video right here. We'll add custom projectiles in Unity. Hope to see you there. So yeah.